Okay, good morning, afternoon, or evening, everybody. Welcome to the Gregory G. Leptuk 4th Online Giovanni Workshop. Today we will continue the workshop with our second webinar, which focuses on how the NASA Applied Remote Sensing Training, or Arset program, incorporates the use of the Giovanni web-based application into their training efforts. This is your host, Jennifer Brennan. It's 2 p.m. Eastern Time, so we're going to go ahead and get started here. What I'd like to do first is go over just a few logistics for today's webinar. To ensure the best audio experience, participants have been placed in silent mode, but if you have any issues or questions, please enter those into the Q&A pod located on the right-hand side of your screen. This works like a chat. Today's webinar is being recorded. The recording will be posted to an online Adobe Connect webinar catalog, as well as to our NASA Earth Data YouTube channel as a separate playlist within a few days of completion. And once this has been completed, what I'll do is I'll send an email to all of the registrants with recording links. Regarding timing, today's webinar will be 1 hour long with 45 minutes allocated to the presentation and an additional 15 minutes for the question and answer period. Excuse me. Once our speakers have finished with their presentations, we will transition to a final, excuse me, we will transition to an optional set of end polling questions, and we'll give these questions usually about 3 to 4 minutes or so, and then from there we'll move directly into the Q&A period. And depending upon how many questions we receive today, we will extend the Q&A period an additional 15 minutes from end time for those of you who may wish to stay on the line, but we do have a hard cutoff of 3:15 p.m. Eastern. You will hear 3 speakers in today's webinar. The first is Dr. James Acker, a senior support scientist at NASA's Goddard Earth Sciences Data and Information Services Center, or JESDISC, and that's located here at Goddard Space Flight Center. He will say a few words about the Giovanni workshop, and then from there, our second speaker is Sean McCartney. He is the co-lead for NASA's Arset program. He will spend the first half of today's webinar providing an introduction to the Arset program, an overview of NASA data products for air quality applications, and wrap up his presentation with an air quality analysis demonstration within Giovanni. Our third and final speaker today is Dr. Amita Mehta. She is a research scientist at Goddard Space Flight Center. She will spend the second half of the webinar with an overview of using Giovanni and Arset water resources and disaster monitor training. All right, thanks everybody. With that, I'd like to turn it over to Dr. James Acker, and he is the workshop organizer for a few introductory remarks. And then from there, we'll transition to today's first speaker. Dr. Acker?
Thank you, Jennifer. I just wanted to say hello to everyone. And I want to thank Sean and Amita for giving this workshop webinar today. I think it'll be very instructive. I was thinking back, and I think Giovanni and Arset have gone parallel paths for quite a while. And I know when it first started up, Giovanni was an important tool, and they've been using that as they add to their curriculum and their breadth of coverage for several years. So I'll be very interested to see what Sean and Amita have for us today. And just as a reminder, next week I will be presenting on both the current status and the future of Giovanni. I'll also be presenting the next selections for the Giovanni Image Hall of Fame, which have been very interesting. There are some really good things we've found in published papers over the past 2 years. And then finally, we'll finish up on July 24th with Dr. Guido Cervone of Penn State University, and he's going to show how Giovanni is used in the classroom and used with statistical analysis for undergraduates. So we have a couple of other good workshops, and I'm looking forward to today's workshop. So I'll give it back to Jennifer and back to Sean.
Today's first speaker, Sean McCartney. Sean?
Thank you. Can everybody see my screen?
I can, thank you.
Great. So I'd like to start by first thanking Jennifer Brennan and Dr. James Acker for the introduction and for inviting the Arset program to participate in the 4th online Giovanni training. Over the next 45 minutes, you will hear how Arset uses Giovanni in our training. Some background on the Arset program and how it fits within NASA's Earth Science Division. As this slide shows, there are 4 elements comprising NASA's Earth Science Division. Arset falls within the Applied Sciences program. The Applied Sciences program works with partners in the public, private, and non-governmental sectors to apply insights from Earth science, combining data, knowledge, tools, and experience to develop solutions and enhance decisions. The Applied Remote Sensing Program, or Arset, empowers local, regional, state, federal, and international entities, including public and private sector organizations, through remote sensing training. One of the main goals is to increase the use of earth science in decision-making through training for policymakers, environmental managers, and professionals in the public and private sectors. The image on the right shows examples of trainings Arset has led on harmful algal blooms, or HABs, flooding, deforestation, and wildfires. Arset achieves these trainings through both online and in-person training. Our online trainings are free, they're online, they're 1 to 5 weeks long, and participants can expect between 1 to 6 hours per week on these trainings. We offer trainings at all levels, from introductory to advanced, and our materials are bilingual in both English and Spanish. For our in-person trainings, we're typically hosted with a partner at either a federal or state agency or at an academic institution. They're typically held in a computer lab so that participants can get plenty of on-hands training as we're going through the training. They're 2 to 7 days long, and they focus on locally relevant case studies. Certain topics are also presented in Spanish. As I spoke to earlier, the Arset training has fundamental trainings, basic trainings, and advanced. And it's expected that those participating in both basic and advanced have gone through at least 1 or 2 of our fundamental trainings so that they're ready for the next level. The focus areas of the program cover air quality, disasters, land, and water. For my part of this webinar, I'll be discussing air quality, but it's really important to note that we constantly have trainings pretty much every month of the year covering these other thematic areas, and I highly recommend you join them to learn more. For air quality trainings, we cover different topics such as how air quality impacts health and how to monitor that using satellite and aerial data, how to monitor aerosols, smoke, as well as dust transport around the globe. Some of the things that we touch upon in our air quality trainings are what satellites and instruments are being used, how to access that data or those data-derived products, what algorithms you can use for your specific case study or scientific analysis, the data and tools, and also the plume transport, different models, trends in air quality, as well as vertical profiles. These are just different things that we touch upon in the trainings that we do with air quality. Lastly, as I wrap up some of the background on the Arset program, I would like to acknowledge that this is our 10 years, and we've had a lot of successful years working with Giovanni, and we're very appreciative of that collaboration. If you would like to learn more, I recommend that everybody go to this website and see our upcoming trainings, as well as all the trainings that we've held in the past, if it's water quality, air quality, disasters, or biospheric processes. So why has NASA designed and built instruments to fly an aircraft and spacecraft to monitor air quality? Through growing population, urbanization, and industrialization, 85% of the world's population now live in areas where the World Health Organization air quality guidelines are exceeded. Air pollution is the 4th highest ranking risk factor for death in the world. As the map shows, the highest concentrations of fatalities related to air pollution are in South and East Asia. satellite data can help quantify the impact of air pollution on human health. Air pollution was traditionally monitored using ground measurements. Now governments can leverage remotely sensed data from aerial and space-based platforms combined with ground measurements and models to improve their monitoring and forecasting. So why do we use satellite and aerial data? As we can see from the map in the upper left-hand corner of the slide, the ground sensor network for monitoring particulate matter 2.5 or PM 2.5 varies greatly across the planet. Higher concentrations of ground sensor networks are located in the United States, Chile, Western Europe, India, and China. This network is very sparse elsewhere. When compared with population density in the lower right-hand part of the screen, we see concentrated populations without adequate ground coverage. Satellites provide a consistent global coverage for regions of the world without an extensive ground-based network. What's more, NASA has a commitment to provide data as free, open, interactive, interoperable, and accessible for research and societal benefit now and into the future. So a satellite picture is worth millions of data points. Each data point can be given a geophysical number, such as a fire in this image. Or in a different data set, it could be a flood extent, a landslide, a forest disturbance, an agricultural crop type, etc. Satellites and planes do not measure air pollution directly, but measure spectral radiances from the sun. This is light from across the electromagnetic spectrum reflected or absorbed back to sensors on a plane or a satellite. Satellites measure a 10 square kilometer vertical column from the top of the atmosphere to the surface. This aerosol optical depth, or AOD, measures the spectral radiance of optical light reflected or absorbed by aerosols, ozone, water vapor, and other gases. One of the instruments NASA uses to measure aerosol optical depth, or AOD, is the MODIS instrument on both the Terra and Aqua satellites. The 7 spectral bands from MODIS used to derive aerosol properties are shown in this slide, shown in micrometers. This slide shows the seasonality of aerosols measured globally by the MODIS instrument on the Aqua satellite. In the winter, the instrument is observing biomass burning during the dry season in Africa. In the spring, we see higher levels of pollution in East China due to more coal-fired power plants being online. In the summer, we see high levels of dust storms around the Arabian Peninsula, as well as dust from the Sahara being carried across the Atlantic to the Americas. In the fall, we can see high levels of biomass burning in the Amazon due to land clearing and agricultural fires that are widespread across the Amazon basin and Cerrado regions of Brazil. Aerosol optical depth is a column integrated value from the top of the atmosphere to the surface. It is an optical measurement of aerosol loading, and it is unitless. It is a function of shape, size, type, and concentration of the number of aerosols. AOD is used to derive particulate matter 2.5. PM 2.5 is a mass per unit of volume of aerosols, aerosol particles less than 2.5 micrometers in aerodynamic diameter at the surface level. Particulates as fine as PM 2.5, are the most harmful form of air pollution due to their ability to penetrate deep into the lungs and bloodstreams unfiltered, causing permanent DNA mutations, heart attacks, respiratory disease, and premature death. This slide shows the relationship between aerosol optical depth and particulate matter. Assuming cloud-free skies, a well-mixed boundary layer with no overhead aerosols, and aerosols that have similar optical properties, AOD and PM 2.5 can be related by the equation below. This visualization was created by NASA's Scientific Visualization Studio based on the Goddard Earth Observing System Model version 5. The GEOS model is built on satellite data and provides a forecast of aerosol optical thickness, among other things. This animation shows a daily updated 10-day forecast of aerosol optical thickness from the GEOS model. The date and timestamp are in the lower left corner, showing a 10-day forecast from July 7th of this month. In general, brighter colors are thick aerosols, while dull, darker colors are thin aerosols. Blue represents sea salt. In the animation, pale blue to white colors reflect stormy conditions. Individual large storms are visible as swirling circles of thick sea salt. You can see this in the southern hemisphere, particularly in the Indian Ocean as well as the lower Atlantic Ocean, southern Atlantic Ocean. The red represents dust, and the Saharan Desert of northern Africa is the largest source of dust, but dust can be seen across the globe. Saharan dust often interacts with tropical cyclones. We can see clearly the dust flowing from east to west across the intertropical convergence zone as it blows from the Sahara all the way to northern South America into the Caribbean. Some of this is even reaching Central America. Green represents the sum of aerosol optical thickness for organic carbon, black carbon, and sulfate. Organic and black carbon come from burning biomass or fossil fuels. Sources include fires, power plants, vehicles, and other combustion engines that run on fossil fuel. Sulfate particles come mostly from burning fossil fuels, but also from volcanoes. We can see this particularly in the case of China and northern India, as well as if we look at the Congo Basin, we can see fires burning as they clear land for agricultural production. To finish my part of the webinar, I will show a few examples of how Arset incorporates Giovanni into our training on air quality. What we're looking at here is the portal to log into the Giovanni portal. First thing you want to do is log in, otherwise you will not be able to access the data that you're wanting. So I'm quickly doing this. Now that I'm logged in, I'm going to select the date range that I'm trying to look at. In this case, I'm trying to look at April from this year. So I'm typing in April 1st to April 15th. I'm now going to create a bounding box around the area that I want to create this data set from. This bounding box will be from roughly central China all the way across the Pacific Ocean to the west coast of the United States. Now that I've created this bounding box, I'm now going to go through the variables that Giovanni provides on the left-hand side. So I'm going to go from aerosols to aerosol optical depth, which is what I was briefly describing. I want the modus aqua instrument. And for spatial resolution, we're going to go 1 degree. And for temporal resolution, in this case, it's going to be daily because I'm looking for specific days from April 1st to April 15th, and I'm going to select aerosol optical depth dark target. And I'm going to be selecting time averaged map for this demonstration. And once I've done that, I'll click plot data. Now this should take roughly 25 to 30 seconds on average, but what we'll be able to see is a time averaged map from aerosol optical depth from that study period, April 1st to April 15th of this year, from East China across the Pacific to the United States. What we can see in this map that was generated is the amount of aerosol optical depth and where it's concentrated the highest, but these colors I'm not really happy with. So I'm going to go into the Options tab, and I'm going to change it from yellow to red, which for me is a little bit more intuitive. So Giovanni gives this feature, which I happen to like. So I'll clear out of the options. Now, for me, this is a little bit more intuitive, and we can see much higher concentrations in East China. And one other option I'm going to put on just for visualization is the smoothing, and this interpolates the data, the raw data that was time averaged, and it just gives a cleaner visualization. You have options to download the data in NetCDF format, GeoTIFF, and KMZ. And you also have other sources to download on the right-hand side of the screen. And now I'm going to go back to the date selection. And now I'm going to change from daily to monthly. And I'm also going to unclick the aerosol optical depth dark target only. And I'm going to select the combined dark target and deep blue aerosol optical depth. I'm also going to change the date range. And because I selected monthly, you can see that the daily option is now grayed out. So I'm going to select from 2014 to 2019 of June. And I'm also going to select a new bounding box. Instead of around the Pacific Ocean, I'm now going to select this bounding box around Central and Eastern China. And I'm going to try to include parts of Southeast Asia. And you know what? I'm not happy with that bounding box. Let me do this one more time. So again, I'm trying to determine aerosol optical depth on a monthly scale for this study region I just selected from June of 2014 to June of 2019. And just like before, as Giovanni processes all the data and does this all on the back end, so I do not have to download any of this data from the DAX. I can quickly compute this analysis just on the fly using the Giovanni portal, which for me is going to save some time and maybe identify some trends on the fly instead of having to go through the data acquisition process. And here I can see some higher levels of concentration in the Eastern China. And again, I'm not super happy with this color grade, so I'm going to change the colors and that Giovanni allows me to do. And that should happen momentarily. And once that is done, we'll be able to see that from a yellow to red scale. And we see the highest concentrations around the Yangtze River, the mouth of the Yangtze River. So now that that's done, I'm going to create a time series of that same date range. So instead of an area average map as a map, it's going to be area averaged over time. So Giovanni gives us the ability to do this as well. So we can hopefully identify some trends that we can see in the data set. And again, this is in Central and Eastern China, aerosol optical depth from June of 2014 to June of 2019. So this runs relatively quickly. Depending on the number of data sets that you use, this will take longer, but this took maybe 15 to 20 seconds. What we can see here is that the aerosol optical depth, or AOD, is actually starting in the early winter and is peaking in the springtime, which is interesting because that's going to tell me something about what's happening in Eastern China around this time. We can see the springtime has the highest levels of AOD throughout each year. So that's a way of looking at the data and visualizing it and computing some quick statistics. Now I'm going to keep that same date range, but now I'm going to change very quickly the study area in which I was looking at. So instead of Eastern China, I'm now going to look at the subcontinent of India, and I'm going to see if there's a difference in trends in aerosol optical depth from that same date range of June 2014 to June 2019. And I'm going to see if I can identify if there's a difference in that aerosol optical depth seasonally from year to year. This is a quick way of looking at the data to identify trends and to see if there's changes throughout different geographies. So here I can see actually AODs peaking in the summer months, not necessarily the spring months. So something that the conditions are different in India than they are in China. So very quickly, just by changing the plot data, I can see very quickly changes in aerosol optical depth in 2 different geographies in the world. So thank you. I am now done with my part of the webinar, and I'm going to turn the webinar over to my colleague, Dr. Amita Mehta, to discuss how Arset uses.
Thank you, Sean. Thanks for your patience, Jennifer. And okay, so I'm going to start from when Sean left off, and he showed Arset Giovanni application for air quality monitoring. I'm going to talk about use of Giovanni in Arset water resources and disaster monitoring and management trainings. I want to start with a list of trainings that you may be able to go back and see. These are all open source. Anyone can download this material or watch recordings of this training. So what I want to point to your attention is that a number of topics listed here, monitoring water
Amita,
river basins. Hello, can you hear me?
Yes, that's better. You'll need to stay right near the speaker so we can hear. Thank you so much. Thanks for your patience, everybody.
Thank you. So here is a list of Arset trainings which focus on water resources and disasters management. And I'm providing links here so that if you want to go back and review them, you can go through them and understand in detail about these topics and different data sets that are used in these trainings. To focus here, today's talk, I'm going to focus mostly on how Giovanni is used in aiding this training that we just talked about, all these trainings. So we did training about monitoring water budget in a river basin, also did remote sensing of drought management, urban flood management, and tropical storms in emergency preparedness. All these trainings, they utilize Giovanni for data search, data analysis and visualization, and data download. And most of these trainings, as Sean just demonstrated, they include demonstration of Giovanni applications. So we guide our participants who may or may not be experts in remote sensing or in using software, but they find Giovanni easy enough to use, and we show them step by step, like just Sean demonstrated, how you would go and do maps or time series and then finally download data. Also, for most of our trainings, some of them which are in advance in training, we use Giovanni together with other software, open source software such as QGIS or Panoply and Excel, so that we do research with Giovanni. We select different domain or time period using Giovanni and then download data and then use other software to do advanced analysis. So what I'm going to do today is I'm going to talk about 3 examples. We're going to talk about tropical cyclones, floods, and water budget management. So I'm going to show tropical cyclone, how we do data analysis and visualization. So I'm going to we use these features, animation and maps, when we're looking at any tropical cyclone. We track precipitation, sea level pressure, and winds using some of the data sets available through Giovanni. I'm going to demonstrate precipitation using a particular data set, which is GPM
iMerge, which is a multi-satellite rainfall product that I will talk about in a minute. I'm going to show an example of Cyclone Idai that occurred over Mozambique in March of this year. This image on the right-hand side, it's from NASA Earth Observatory and from Moody's instrument flying on Terra satellite, and it shows where it was located. You can see the structure and clouds from this optical sensor here. What we are going to do is we're going to look at precipitation, how it changed with time and where was it maximum using this iMerge product. Okay. And next, we're going to look at an example, which is data analysis and visualization for extreme precipitation. How can you look at past data and come up with probability or some kind of assessment of how precipitation varies over a particular location? And so for that, we're going to use time series analysis. We can also look at climatology of precipitation, and we can also do histogram to see distribution of rain rates over a particular location. For this example, I will use data set which is Tropical Rainfall Measuring Mission, TMPA, or Multi-Satellite Precipitation Analysis, and we'll focus on City of Houston for urban extreme precipitation. And we will see how you use Giovanni and different features to get assessment of how precipitation varies over a small location. This is very useful for not only planning if there is extreme precipitation occurring currently, but you can plan for future, where exactly and when exactly relief or rescue may be needed because of precipitation and flooding. Because of that, this is a very popular and important topic that we teach. So before I show the demonstration of these two examples, Cyclone Idai and extreme precipitation, just about a few words about the data set that we use. So precipitation from TRMM and GPM, these two satellites, they are NASA satellites in collaboration with Japanese Space Agency. They both carry precipitation radar in space in addition to microwave passive radiometer. And both TRMM and GPM use a constellation of satellites from around the world, from other agencies such as NOAA and TMSP, but also from international agencies such as European Space Agency and ISRO, and Japanese Space Agency, JAXA. So these constellation satellites also have microwave radiometer, and they measure microwave frequency radiation, which is all used and calibrated by TRMM and GPM radar to come up with a multi-satellite product or multi-satellite algorithm, and that provides a good temporal and spatial coverage of precipitation over most of the globe. Both these data are available in Giovanni, and we use them very widely through Giovanni for our training. So iMerge is special in the sense that it has 3 versions. GPM, which was launched in 2014, it's providing this data since, and now iMerge will be extended backward to cover TRMM era also. So in very near future, there will be a combined TRMM GPM product that will be available. The nice feature of this product is that there is early version, which has 5-hour latency, and that is very useful for monitoring flash flooding. Similarly, there is late version, which has 12 hours of latency. It can be used for planning crop irrigation. And then the final one, which is a research quality product, it has latency of 3 months, but this has rain gauge data assimilated with satellite data. And so that is used for research, and also if you want to look at past data, this is a good product. These data are available at 1/10 of a degree latitude longitude, and it's covering tropics and mid-latitude, and soon it will be produced to cover pole-to-pole region. The temporal resolution is half-hourly, and so this is ideal in monitoring. If you use early and you use half-hourly, you can monitor arriving or approaching tropical storm, or you can follow a precipitation system, how it is evolving and moving. And so these data are quite useful, and we use that through Giovanni. So TMPA that I'm going to show for extreme rainfall is quarter degree resolution. It's every 3 hourly data. It has long time coverage. iMerge, which is relatively recent, 2014 onwards, has higher resolution, 1/10 of a degree, and it's every half hour. And we're going to see some of these animations soon, how we monitor tropical storm and precipitation using this. So this is Giovanni interface that we will see, but basically it allows you to do keyword search for any geophysical parameter that you may be interested in. There is temporal search, there is spatial search, and there are also multiple set analysis options. As Sean pointed out through his analysis, what is convenient about Giovanni is that you can vary quickly time domain or temporal domain without really downloading data, without going through a lot of analysis. Otherwise, you would have to download data and write software or program to do that. Here, Giovanni allows you to do that very quickly, and you can, that way you can do research quickly and decide where you want to focus for detailed study. Next, what I'm going to show. So we are going to look at tropical cyclone, extreme precipitation using TRIM GPM data. And then we're going to look at water budget analysis, which uses Giovanni along with QGIS. And I'm going to show an example of Potomac River Basin right here outside in Washington, D.C. What we can use, we're going to use is maps and time series. And we're going to use a particular data. It's Global Land Data Assimilation System, or GLDAS. And what GLDAS does, it has input from weather information. So it uses trim rainfall, TMPA, as forcing. Also uses other weather data, such as winds, temperature, radiation at surface from global reanalysis. Also uses boundary conditions from vegetation mask, land water mask, leaf area index, etc. from MODIS. And there's cloud and snow that also they are available from other satellites from NOAA and DMSP. And it provides integrated output such as soil moisture, evapotranspiration, surface and subsurface runoff, and snow water equivalent. All these are very important for estimating water budget or just understanding how water is cycled through a river basin. Water budget management is a major issue right now. As you know, water is a scarce commodity and it has such high variability in space and time that monitoring closely all these water budget components is very important, and satellite data, they help in doing that. GLDAS data are available at quarter degree resolution every 3 hourly and monthly through Giovanni as shown here, and it has a coverage since 2000 to present. So it allows you to look at water budget and its history since 2000 over any selected domain. So with that, what I'm going to do is start with demonstration of tropical cyclone. And I'm going to switch to a Giovanni data selection that I have here. Sorry. So here I'm going to start with iMerge precipitation that I just talked about. It is GPM iMerge. Once you type a keyword iMerge here, it provides you all the options of iMerge availability, early, late, and final. We're going to pick final for this particular example. You would sometimes see multiple versions, 06, 05. It is recommended that you use the latest version because there are improvements from version to version. So we're going to pick the latest final version, and we're going to look at daily accumulated precipitation. And I have selected a domain which is covering Mozambique and nearby area where the cyclone emerged and traveled. This is Cyclone Idai. But also know from the past data that it was intense between 11th to 15th or 16th of March. And so these are the days are picked here. And for analysis, it shows animation here. You can pick animation. And here, then when you say plot data, it takes a few minutes, but you can see precipitation. And then here I already have this animation. I'm going to play this for you. You can see the dates changing here. And you can see this is daily precipitation from IMERGE. Again, this is 11th, 12th, 13th, 14th, and 15th. So this is showing how it's approaching coast of Mozambique and then makes landfall and then it moves inward. You can see other spiral bands extending all the way up here also. Now, this allows you to focus on a particular time and day if you're going to do research, if you're going to come up with if you see past data and you can see multiple storms, you can come up with the area where most storms landfall on this coast. You can come up with probability of where storm would be occurring, landfall will be occurring. So that way, animation features, without really downloading data, without doing much, you can go through a number of storms, watch animation, and come up with areas or coastline or inland area where storms again and again are affected. So this is one example where animation can help in looking at what else can you do is that once you already know from this animation that between 14th and 15th, a lot of rain and impact occurred here because of the landfall of Idai. So what you can do here now is you can go back and look at, you can change the date now here. You can go to, not only that, you can search for IMERGE and you can go for half-hourly data. So you can look at half-hourly data and you can pick appropriate date here from 14th to 15th. And when you look at half-hourly data, you will also get an animation. You can do the animation. And here is the animation of half-hourly data. So this is between 14th of March and 15th of March, every half hour. So you can see the speed and track very clearly and where all precipitation, how it spread over time. And as you can see, as it moves on land, you can see these outer bands bringing rain to other regions also. So this allows you to do first some qualitative animation and just get the feeling about how the storm is moving, where it is heading. You can do this with near real-time data by using real product. And then you can do more quantitative analysis by downloading this data. So Giovanni allows downloading data as GeoTIFF. And here is what we've done is done 14-15 March accumulated rainfall from IMERGE. This was downloaded by using Giovanni. Once you do the accumulated map of rainfall, you can download the data in GeoTIFF format. And then this is then imported into QGIS. You can see that once it, not only over ocean, of course, and coastal region has much higher rainfall accumulated, but over land you can see which urban center actually had more rain, which area received the largest amount of precipitation in these 2 days. So you can overlay in GIS different layers such as population or terrain or other infrastructure data, and then you can use this information for decision making. So starting from data, going through quick analysis, qualitative analysis in Giovanni, and then finally actually downloading data and doing quantitative analysis using additional software usually helps. Next, what we're going to see is extreme rain over Houston. And what this uses, it uses not animation or maps, but it uses time series as Giovanni uses time series, feature of time series, and then you can go back to data and you can search iMerge and do time series here. Okay, here's TMPA. I'm going to do trim time series because I am interested in long-term and here you can see there is 3 hourly monthly precipitation. I can choose monthly precipitation, and these are long-term data sets, so I can go all the way from 1998 January all the way to 2018 December if I like. Another feature to see here is that there is seasonal or interannual time series. You can choose that, and this allows you to choose each month or each season separately. If I choose all 12 months here and then choose year from say 98, okay, it should be working. Okay, and so suppose you take this and now you can change this for a location of your interest. I've chosen this location over Houston, and then once you say plot time series, it takes a few minutes, but what you get is a time series shown here. So this is interactive time series. If you do this on Giovanni, you can point here and see which month and how much precipitation there is. So this is, all these are years, these are months. So you can see which month usually has high precipitation rate. So this is in millimeter all the way up to this. The highest rainfall you see here is around about 700 millimeters, and you can see that this is in 2017 associated with Hurricane Harvey. You can also see this earlier, this is in June, this was Tropical Storm Allison, and what you can see is that overall most months do have precipitation within 200 millimeters, but then you can see that there is June, there's some winter precipitation like January in some years, and then mostly when you have hurricane approaching or tropical storms approaching, you have very high precipitation. What this allows you is that you can look at this time series and come up with standard deviation. You can download these time series as CSV files using Giovanni. You can do anomalies or add and find climatology, and you can find standard deviation month by month. This gives you assessment of how, what is the nature of precipitation over this particular location. So month after month, you can actually monitor it and see whether it is within the range, is it outside the range, how would you manage if it is really higher or lower. So when you look at monthly, it gives you idea about more rain or less rain monthly, allows you to plan for if there is flood condition, drought condition, there is excess water or deficit of water. So what you can do is that you can use a feature in Giovanni, which is histogram. If you go to miscellaneous, you can see histogram, and you can do histogram of this. And so what you see here over Houston, this histogram was created now by using half-hourly data, and this was for 26th of August to 28th of August when Hurricane Harvey made landfall and it dumped a lot of rain over Houston. And the histogram here shows that the total number of data points were about 384, and it shows how many beams are here. It shows mean rain rate, half-hourly. It shows standard deviation, maximum and minimum, and it shows distribution that for this particular hurricane, you can still see that there is a moderate to high precipitation rate had quite a few numbers. Of course, most of them are below 10 millimeter per half hour or hour. Here you can see that most of these extreme rain beams are still seen. So you can do this type of analysis for many different precipitation events and come up with probability of precipitation being within certain range. And this allows you to plan for a heavy precipitation along with socioeconomic data. If you have damage data associated with particular hurricane, you can do co-analysis with this information and damage assessment from the past. You can put this together in GIS or any other software and then do actually disaster risk reduction analysis by using this multiple data sets. So that way, these features help in Giovanni in analysis. Next, I want to show this water budget analysis, and then I will conclude this talk. What you see here is I have chosen GLDAS. Again, if you go and pick GLDAS, you can see I have picked total precipitation, there is evapotranspiration, surface runoff, and then base flow. This is the subsurface runoff. And I've chosen these for this box. Potomac River Basin is within this box. However, you can also see that there are also ways you can select different watersheds. There are major watersheds available through here. So if you want to pick, say, any river such as Mississippi, Missouri, it's available here. Danube is available here. So there are major watersheds. If you are interested, you can go ahead and pick this watershed here. Since Potomac Basin is relatively a smaller basin, it's not available, so I've chosen this box. And then I have looked at first time series of these parameters, so total precipitation between 2016 to 2019, and you can see that 2018 summer had higher rainfall than previous years. You can also see month-to-month variation within the basin. This is basin average rainfall. You can see that this is the runoff. Again, it is higher as rainfall gets higher, and it is lower, it's relatively lower where there is lower rainfall is there. In addition, you can see that this is the base flow, or this is subsurface runoff. It also follows somewhat the rainfall pattern. Evapotranspiration, on the other hand, is strongly affected by vegetation. And so what you see here is that this time series has strong annual cycle peaking in spring to fall and peaks in summer where the vegetation is highest and evapotranspiration is highest. So over basin availability of water will depend on all these components. You can also look at maps of these. If you go back and just look at maps, these examples are shown for a season, growing season of May to September 2017. This is from GLDAS, and this is quarter degree, so you can see a little boxy grids here, but it provides you, roughly you can see here there is more precipitation than over here. It gives you relative idea of how these parameters are distributed, especially over the basin. once you have this data, you can download, and there are multiple options. These are also useful. You can download NetCDF file if you are interested in using R or Python or MATLAB or IDL kind of software to do analysis. You can have TIFF or KMZ. You can see it with Google Earth. You can use TIFF with geospatial analysis or any GIS, and that's what we usually do. We use GeoTIFF with QGIS to do further analysis. And that's finally I want to show here to my slides. So what you can see next is the river basin. And so what we have done, I showed all the parameters here. So precipitation is the source, and how water is distributed or goes out of the basin is through evapotranspiration and runoff. And whatever is remaining is the storage in terms of soil moisture or subsurface soil moisture. So you can use in GIS, what we have done is we downloaded the GeoTIFF images, got all precipitation, ET, and runoff in here, and did the water budget analysis. So what we did is that storage over a long-term period stays very small, and so precipitation is balanced by evapotranspiration and runoff. That's the assumption here. And based on that, we have done this water budget analysis. So what you see here is actually water budget for 2018, and then there is 17 that I will show in terms of this Excel table. What GIS allows you to go through these subbasins and basins. So we did this water budget analysis for 17 and 18, and this is the area of the basin. So you can get this water budget, so precipitation minus evapotranspiration minus runoff, and this is in cubic meters. So this gives you an idea of, for this subbasins within Potomac basins, there are about 9 of them, and you can see that each subbasin, how it, from year to year, how these components changed, overall water balance changed. Here you can see that there is negative numbers, so deficit of water, so evapotranspiration and runoff were more than precipitation. Here, more or less, they were more. They compensate, and then so there is more precipitation. So by using Giovanni's features, we can not only do research, we can do more quantitative research by using additional software also. And so I want to conclude my talk here. On behalf of Sean and myself and Arset group, we want to thank Jennifer Brennan and also Dr. Jim Ecker for giving us opportunity to talk about training and how we use Giovanni. And so in summary, what we talked about was how we use Giovanni for data search, analysis, and visualization, and download. And most of our trainings do include demonstration of different features of Giovanni. And as we saw some examples here, if we've used it for air quality, tropical cyclone, extreme rain, and water budget analysis. So thank you, and if you have any questions, we can answer them now.
Okay, thank you, Amita. Just in light of the time, today what we'll do is we're going to go through the Q&A first, and then I will open up the polling questions for those of you who are able to stay on for a few more minutes to fill out, to provide some feedback on today's webinar. So let's go ahead and get started with the Q&A since we're already in of MODIS satellite and Giovanni. So that's your first question here. So I guess, can we access MODIS satellite data in Giovanni?
This is Jim. I can address that. You can only get the level 3 MODIS data, which is the map data. We're actually expanding our level 2 subsetter. Probably won't include MODIS because MODIS is not a data set that we archive. We get it in Giovanni from another data center. But we are getting several data sets that are subset with our level 2 subsetter. So in order to get MODIS data as an orbital type, you would have to go to their data center.
Oh, and I wanted to make another mention here. You can actually access the MODIS orbital path in Giovanni, in using Worldview. So I have the link up there just above. It's the Worldview earthdata.nasa.gov. And I can email you separately for this user and just give you some tips on how to get there. Okay.
I think the Ocean Color group can also give you overpass predictions for MODIS because they get the ocean color data from MODIS as well.
Right.
Yes,
okay, wonderful.
they do provide predictions.
I want to mention one thing. I want to mention one thing really quick. Amita showed the interactive time series, and she showed a plot with all 12 months, which was very interesting. And one thing you can do, they may have shown this in the training, but when you've got the interactive time series on your screen, you can actually deselect certain months. So you could have actually looked at just the hurricane season with August, September, October, November, if you didn't want to see all the different plots. I thought that was really good because it showed the annual, all the months, but then you could isolate on some of the hurricane months.
No, yes, you're right. We usually just focus on that. I just wanted to show the feature that.
Yeah, it was excellent. It was really excellent. And I just wanted to point out that because it says interactive at the top, that's what it means. You can put in and take out particular months.
Right, right.
Okay, great. Thank you, Jim. And just while we're waiting on any further questions, a couple of notes. In the lower right-hand corner of your screen, you will see a PDF version of both Sean's and Dr. Mehta's presentation today, as well as the two videos that Sean showed. So you have the air quality demo along with the aerosols, the first animation that you could see today. And so, okay, so I'm sending this out now. If you're interested in signing up for additional data discovery and data access webinars, you've got that link there. Let's check one more time for any additional questions. If not, we will log off from the audio component of today's webinar, and I'm going to pull up the polling questions for those of you who are interested in providing feedback. At this point, I do not see any questions, so why don't we go ahead and pull up the polls. We've got a little bit less than half of our participants, and if you could provide some feedback, that would be excellent. Thanks again for your patience today. And all right, thanks, everybody.
Thank you. Thank you. Thanks, everyone.
Bye.
Bye.